let us forget about machine learning for a little bit and let's quickly do a quantum dot primer section on introduction to the charge stability diagrams. You already covered charge stability diagrams in your recommended prerequisite reading for this course, but let me quickly review them so we set up our language, terminology, and notation for the machine learning tasks that will come up in the next submodule. So you know that quantum dot in a drawing level of abstraction looks something like this. You have a dot here that is separated, isolated in all the three spatial directions by some gate. And then you can watch what happens in your dot by having this extra electrode that is called quantum point contact. This can be implemented experimentally in many different ways. But you can measure a current that goes through it, and just by the art of Coulomb interaction, this current carries an information whether there is an electron sitting in your quantum dot or not. If we look at how this looks on a real device, this is the electron tunneling microscope picture from our experiment from Zurich in 2020, where we have 3 quantum dots. Now you see that they are defined by many different gates. And then we also have this extra electrodes that will help us to use this QPC current to measure what's happening in the dot. For our purposes, only some of the gates are important, and those are the so-called plunger gates. This first one controls what happens in the dot number 1. The second one controls what happens in the dot number 2. And the third one controls what happens in the dot number 3. And then we have this QPC current that we have access to through a measurement. So if we have a device like this and we start measuring this current, we can then plot a figure that looks something like this. This is called a charge stability diagram. And what you have here is the voltage on one of these plunger gates on one axis, voltage on the other plunger gate on the other axis, and your color scale tells you the change in your current, specifically the derivative of your current with respect to these voltages. So if you look at that, you see that there are these really dramatic changes, jump features, that tells you that basically something happened in one of your dots. So if we look at the vertical line, we will see occupation changes in the dot 1. And if we look at the horizontal line, we will see occupation changes in a dot 2. So you see that you can have a many different ways the charge transitions can happen in these charge stability diagrams. We are not going to discuss where the physics of these directions come from, but it's important to have in mind that outside of the fact that you can see dot 1 or dot 2 only, or you can see both dots, there is a lot of diversity in how the lines can go. And what we are going to learn in this module is how to use neural networks to classify whether you are seeing both dots or whether you are seeing only one dot.